You'll be shown how to weld aluminum open corner and T-joints in the flat position using the gas metal arc welding process. Prior to performing this lesson, you must be able to run string beads and weave beads in the flat position. As in all welding operations, safety is number one. You must remove ID tags and all jewelry. Your wedding band may be taped to your body to prevent electrical shock. You must also wear protective equipment to include eye protection. Welding cap, welding helmet. Inspect the helmet to make sure it has a number 11 lens. The production and intensity of the ultraviolet rays are much higher in comparison to metal arc welding. A welding apron, a welding jacket, a pair of welding gloves, and hearing protection. Make sure you have ventilation. Now prepare the equipment for gas metal arc welding. You'll be using the Lincoln arc welder in this demonstration. It is capable of performing gas metal arc, gas tungsten arc, and shielded metal arc welding. Caution: it is very important your setup is correct to prevent damage to the equipment and to personnel. Now turn your electrode polarity to the DC positive position. Caution: ensure the machine is off before making your adjustment. You can be held financially liable for your negligence. Flip the current control toggle switch to the TIG 300 position. Turn the current control knob to 3.5 for your starting reference point. If you need to increase the heat, turn the knob to a higher number. To decrease the heat, turn the knob to a lower number. Check the spark switch. Make sure it's in the off position. Caution: if it is left in the on position, it can burn out the wire feed box. Flip the soft start switch to the off position. You must flip the welding mode switch to the stick welding mode. Don't leave the switch in the inert gas welding setting, which is for gas tungsten arc welding. Turn your current range selector to the maximum output. Now open the wire feed box. Back out the tension adjustment wheel counterclockwise all the way. Now, turn the wheel clockwise 2.5 turns. Increase or decrease tension on the wire as needed by turning the knob. There is a notch to reference your turns. The wire feed mode must be flipped to the constant current position. Ensure your dial range toggle switch is in the high position to use the outer dial on the wire speed. Speaking of the wire speed, it should be set at 650 and adjusted as needed. If set too low, burnback will occur. This is where the wire burns back into the contact tube as shown here. Now let's look at the polarity switch. Remember, it must be in the positive position for this operation. The wire feeder clip must be grounded. Next, turn the argon cylinder valve counterclockwise all the way, allowing the argon to flow to the regulator. Turn the flow meter so you can read the argon graduated scale. Turn the wire speed to the lowest setting to conserve wire. Now turn on the machine. Squeeze the trigger on the gas metal arc welding gun. Caution, the electrode is electrically hot and will arc. Adjust the flow meter so the top of the ball reaches the 40 cubic feet per hour on the argon scale. Release the trigger. Turn off the welding machine. You must turn the wire speed back to 650, otherwise you will experience burnback. Take your wire brush and clean the metal. This should be done just before welding to prevent the metal from contamination. Now position and tack weld 4 each, 1/2 inch by 2 inch by 6 inch aluminum plates to create a big box. Your tack welds must be on the inside of the plate to prevent interruption in the welding path. After tack welding, your box should look like this. Now align and tack weld your wings, which are 1/4 by 1 1/2 by 6 inches on each edge. This will form the T-joints as shown here. Now wire brush all the tacks on the big box. Place a weave bead 1/2 inch in length on top of each tack weld, as shown here in slow motion. This will prevent the breaking of the tack weld under the stress of welding. To run our first bead on the T-joint, we must use the jig to adjust to a flat position. Then wire brush to clean the metal. To run the penetration bead, use the forehand technique, holding the gas metal arc welding gun at a 90-degree angle to the work. And then tilt 5 to 10 degrees away from the direction of travel. The forehand technique is preferred for aluminum, as it provides a cleaning action ahead of the molten weld metal, which promotes wetting and reduces base metal oxidation. However, the drag method may be used depending on immediate circumstances. Wire brush your bead. The bead should look like this. Run your second bead, a weave bead, pausing on each side of the bead. This will allow the filler metal to fill in and prevent undercut. Now turn off the machine. Wire brush your weld. And quench the workpiece. The finished weave bead should look like this. Now run the final weave bead, or cap bead, as shown here. Turn off the welding machine, wire brush the weld, and quench the workpiece. Now have your work evaluated. The final weave must be no less than 3/4 of an inch and no more than 1 inch wide. Now that you have mastered the T-joint, the open corner should flow smoothly. Your setting for the open corner joint is the same as the T-joint, as you are still in the flat position. Position the open corner in the jig so that it is in the flat position. Deposit the first bead in the same manner as the T-joint, 90 degrees to the work, and tilt 5 to 10 degrees away from the direction of travel. The bead should look like this after wire brushing. The second bead is a weave bead. Don't forget to pause briefly on each side to prevent undercutting of the metal. After wire brushing and quenching, the bead should look like this. The third bead is a weave bead. Ensure you incorporate the corners as shown here. When finished, the toes of the weld must cover the corners of the joint, not to exceed 1/16 of an inch. Now, let's review. How many beads are required and what type are used for an open corner? The answer is 3. 1 is penetration, and 2 and 3 are weave beads. What angle is the gas metal arc gun held when welding a T-joint in the flat position? The answer is 90 degrees to the work and 5 to 10 degrees away from the direction of travel. If the wire feed is set too low, what will happen? The wire will burn back into the contact tube. This completes the demonstration on how to weld a T-joint and an open corner joint in the flat position. If you have any questions, view this tape again. If not, return to your work area and perform this task.